Okay, this is problem 17 from chapter 16 of the textbook Stats Modeling the World, second edition. So it looks like we have a consumer organization inspecting new cars, and they're documenting the type of defects they have, appearance defects. So dents, scratches, paint chips, not major functional defects. So none had more than 3. So apparently they're giving us all the information. So let's just see if we can build a model. So we'll have a random variable x and then p of x. So x will be the outcome. So let's just call x, like up here, let's say x equals the number of defects. So I suspect it looks like you can get 0 and then 1, 2, and 3. Okay, so let's see. 7% had 3, so 0.07. 11% had 2, so 0.11, and 21% had 1 defect, 0.21. And they didn't tell us what this is, but we should know that this value, this has to sum up to 1, so it's going to be 1 minus the probability of 1 defect, or the probability of 2 defects, or the probability of 3 defects. Okay, and that comes out to be 0.61. So I get 0.61. I want to just double check, get the old trusty calculator out, and let's say 1 minus 0.21 minus 0.11 minus 0.07. There it is, proof. Okay, so now we have our probability model, and it says find the expected number of appearances. So that would be the mean. So the expected number of x, I always like writing this notation out. That's going to be the sum of the outcomes times the probability of each outcome. So it's going to be 0 times 0.61 plus 1 times 0.21 plus 2 times 0.11 plus 3 times 0.07. And that comes out to be 0.64 defects. Okay? Now, let's see. I believe they also want to know the standard deviation. There it is. They want to know the standard deviation. So, the standard deviation is the square root of the variance. So let's do the variance first. The variance is the sum of the outcomes less the expected value squared times the probability of the outcome. So that's going to be 0 minus 0.64 squared times the probability, so 0.61, plus, then the next one is 1 minus 0.64 squared times 0.21 plus 2 minus 0.64 squared times 0.11, and then finally plus 3 minus 0.64 squared times 0.07. So you have to punch that up on the calculators. That comes to 0.8704. So again, that's the variance. That's the variance. So to get the standard deviation, you have to take the square root of that. 0.8704. And that comes out to be 0.93 defects. That's the standard deviation. Now, if you want, I don't know, develop a habit. If you want to start with the square root of the sum of the outcome minus the expected value squared times the probability of P of x. You want to do it all in one shot, be my guess. Sometimes if you do it my way, what happens is you forget to take the square root, and so you get a point or two taken off at the end. But this expression might be a little intimidating, and it's not easy to, if you're trying to do this all in one whack on the calculator, it's not easy to hold that square root. Okay, that's how you do this problem. I hope that helps.